Once again, if we look at this question, there are 4 distinct parts to it. The child walks 3 meters north, then 7 meters south, then 2.5 meters south, and then 5 meters north to end it. They want to know their final displacement and final distance. Since distance is a scalar, let's start with that one. It's probably easier. Distance is just all those parts added together. And I've got 4 parts. I don't have to worry about direction at all. So all I do is I simply add the numbers, as long as they're all the same units. And when I add all those together, I get 17.5 meters. So his total path length, total ground covered, is 17.5 meters. Now displacement is a vector. So if I draw it in order, he starts by walking 3 meters to the north. Then he changes direction. So if I go to tip to tail and watch 7 meters to the south, and then he continues south for another 2.5 meters. And then he changes direction and comes 5 meters back in the north. And we're looking for the final resultant, which is the gap. It always points from start to finish. So we're looking for the value of that little gap. And if you just look at the numbers, again, because they're all parallel to each other, we can actually simply add up negatives and positives and it should work. So my total displacement, if we say north is positive and south is negative, would be positive 3 plus negative 7 plus negative 2.5 plus positive 5. And all of that will equal, we've got negative 4, negative 6.5, add 5, negative 1.5 meters. So since negative is south, I would say my total displacement is 1.5 meters south, which you can see would be true on this diagram. I've got 9.5 units down, and overall I've got 8 units up, so that little gap must represent 1.5 units.